Hello, as promised, this is the review, Algebra Review 2. So the answers for the first review are posted in the Google Classroom. I'm going to walk through these problems. So if you're stuck on a problem or if you have completed this entire worksheet, then go ahead and watch this. If this is your first time looking at this review, make sure to try it on your own before I go through it. So the first problem, I already wrote most of this out so that this video would be shorter, and then that way you can see the work, but it also can get out to you faster because my computer has been taking a very long time to upload things to the classroom. So that is why I've already done some of the work so that this goes quicker. So number one, our answer is 7. And this is evaluating the expression when n is equal to 3. And so our first step is plugging 3 in for n, which I did right there. And I put parentheses around that to show that this is replacing n. So this is also 2 multiplied by 3 because 2n is 2 times n. So then we go through following PEMDAS, and we get 6 plus 4, and then 10, and then 3 minus 10 is equal to negative 7. Number 2, we have we have 2 variables this time. This time we take the 4 and throw it in for x, so that goes in 2 places. It goes right there, and it comes over and it goes right there. And you notice I put parentheses around the exponent here just to show that 4 is going in, and I put parentheses around 4 when it goes in for x. And then there's 1 that goes in for y, and we'll put parentheses around that right there. So then we just follow PEMDAS. So the first thing that we do is exponent. So I'm going to do 4 squared, which I take everything else down. So I have 5 times 16. 4 squared is 16. Plus 9 divided by 1 times 1 to the 4th. And 1 to the 4th is just 1 times 1 times 1 times 1, which is equal to 1. And then I'm going to divide and multiply right away. So I start here. I get 80. Plus, and then 9 divided by 1 is 9, times 1 is 9 as well. So I get 80 plus 9 is equal to 89. Number 3, we plug x in. So it's important to have the parentheses around where you're substituting in, because you notice that this negative 7 becomes positive because there's 2 negatives. So I'm going to throw everything in, and then I do my exponent, so I get 49, because negative 7 times negative 7 is 49. And then I also got rid of the negatives and made this positive in that step. So then I do 2 times 49, I get negative 98. And then I add and subtract left to right. So 15 plus 7 minus 98 is going to be 22 minus 98, which is negative 76. Number 4, I plug 4 in, and I'll put parentheses here too to show that that's where x was, and I substituted in. I have to take care of the numerator first before we can divide, and so I get 20 plus 8. So 28 divided by 4 is equal to 7. Moving on to 5 through 8, you can see that the product of 9 and x squared. So the product is our operation, and is where that operation goes. So we have 9, and that's what the multiplication sign is for them, and then x squared. So we have 9 and x squared. So 9 times x squared. The difference of 17 and the quantity 7 minus 8. So when we have and, we have some stuff to the left, we have some stuff to the right. The difference means we are going to be doing subtraction. So I have 17 minus, and I throw that in, 17 minus, and then the quantity. So I put parentheses around, and I threw 7 minus 8 in there. So it's exactly as it reads. All right. So the next question is going to be 6 is at least the sum of x and 5. So 6 is at least. So they're kind of throwing us off because we're going to have the inequality right away. So we write down 6. We write at least, so it could be more. So this is going to be greater or equal to the sum, so plus, of x and 5. So the sum plus goes where and is, of x and 5. Number 8. So I have 4 less than a number squared. So I used x as my number. You recall that when we see less than in this context, you write that blank minus 4 and then whatever this is. So a number squared, so x squared. And then is more than 19. So it is greater than 19. So x squared minus 4 is greater than 19. So greater than and 19. Okay, we're going to move on to 9 and 10. So evaluate each expression. So you notice that I actually made a tiny little error here. I had 5 initially, but then the answer is indeed 9. So negative 29, I can rewrite that so it's a little neater. But we just start going left to right. So I did 5 minus 18, negative 13. Everything else drops. Negative 13 plus 3 gives me negative 10. Everything else drops. Negative 10 minus 27. Everything drops. Negative 37 plus 8. And that is where you get negative 29. For number 10, I'm going to have 6 minus 3 times 2 cubed plus 9. I have to do the exponent first. And I do that, I get 8. So I get 6 minus 3 times 8 plus 9. We multiply then. After there's no parentheses, there's no exponents. So we multiply. So we get 6 minus 24 plus 9. Then we all have addition and subtraction. So we go left to right. So 6 minus 24 plus 9. Negative 18 plus 9 is going to be negative 9. And 11 and 12 is done in a similar fashion. So first we do our exponents, then we do parentheses, and then we do addition to get our answer. For 12, we do our exponent, then we do division, and we multiply, and then we do subtraction, giving us negative 26. For 13, A and B, and 14, A and B, we're supposed to tell whether each relation is a function. So when I look at 13, I see a relation. So to determine if that is a function, I'm just going to do a vertical line. And I'm just throwing them down. And as you might already know, it's going to pass. So yes, it is a function. For B, I started throwing my vertical line down. And no, it is not, because it crosses here, here, and here. So that is going to be no, it is not a function, because it does not pass the vertical line test. When we go to 14, I look at each of my x's. So 6, 4, and 3. None of them are the same. So that's a good sign. And then we got 6 goes to 9, 4 goes to negative 6, and 3 goes to 9. And that's actually going to be okay, because we have our inputs of 6, 4, and 3, and our output of negative 6 and 9. So 6 goes to 9, 4 goes to negative 6, and 3 goes to 9. So it is okay if multiple inputs go to the same output. It's not okay if multiple or if one input goes to multiple outputs. So think of that vending machine. 6 takes us to Oreos. 4 takes us to Snickers. 3 takes us to Oreos. That's okay. That's completely fine. It works out. B. This is what we were just talking about. So if we think back to our vending machine, 2 could give us, say, 9 is Snickers. Well, it could give us Snickers, or it could give us, say, Oreos. So that doesn't work it's not a function. So it is not a function because this input of 2 has more than one output. Moving on, I'm going to look at the domain and the range. So domain, we can use a vertical line and we can go across, and I can see that it stops right there. And this is 1, 2, 3, 4, 5, 6. And it's an open circle, so parenthesis. So -6, and that goes to 1, 2, 3, 4, 5, 6. And that goes to 6. So all these x values are present. That is our domain. Then our range, we start from the bottom and we start going up. So boom, I hit that point. So that is starting right here. And I continue going up. And I'm going up, 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 up. And right there is the last, right there. And so I'm going to put that line and I'm going to go up. So looking here, I count down -1, 2, 3, 4. So our range starts at -4, and it's going to be parenthesis because an open circle. But then as I go up, I go 1, 2, 3, 4, 5. So 5 is going to be the top end of our range. And you notice that line actually hits, it touches 5. So that is going to be included. Here we're going to, so we used interval notation here. Here we have a collection of points. So we're going to use a set notation. So I'm going to use that, the set notation for domain. And we're going to have, this is 1, 2, 3, 4, 5, 6, -6, comma -2. This is going to be -3, comma 2. This is 2, comma -2, and then 1, 2, 3, 4, 5, 6, and 0. So my domain is the x value. So -6, -3, 2, and 6. And then I close. Range is going to be the y values. So -2, and that is actually twice, but I'm going to continue up. So -2, 0, and 2. Next, we're going to talk about the quadrants. So determine which quadrant each point is in. Well, quadrant 1, 2, 3, and 4. So point A is in quadrant 3, B is in 1, and C is in 2. Remember that backwards clock. So 1 o'clock is right here, and then we start going to the left. I'm going to go through the true and false now. So all functions are relations. That is true. All relations are functions. That is not true. That is false. And that's because if I graph something like this, that is a relation. But if I do the vertical line test, it does not pass. It is not a function. A function has one input that goes to a specific output. All right, so number 18. So true or false? All whole numbers are integers. While whole numbers are 0, 1, 2, 3, and integers are -2, -1, negative or 0, 1, 2. That goes on forever and that goes on forever. So yes, that is true. All whole numbers are integers. 19, all integers are whole numbers. Well, that's not true because -2 is an integer, but it is not a whole number, so that's false. Let's think of an example for an irrational number. Well, pi, that is an example. E is also an example. 21. The domain can be called the input or x values. The range could be called the output. And y values. This is what we're looking for, input and output though. And then what is another name for the point 0, 0? So that's right at the center of the graph. That is the origin. All right, that is all I have. That is the entire answer key for the segment. So if you still have questions, please reach out and send me an email, and we will make sure to help you. Have a nice evening.